Suppose we have a random variable x that has a binomial distribution with n equaling the number of independent trials and p, little p there, is equal to the probability of a success on a single trial. Then x is going to compute the number of successes in n trials. So suppose we want to compute the probability that x is less than or equal to k. That means we're asking what's the probability that we have at most k successes in our n trials. The way we do that is we compute the probability that x equals 0, so 0 successes, and then we'd add on the probability that x equals 1, so 1 success, and then we just keep on going all the way up until we get to the probability that we have exactly k successes. Now each one of those separate numbers, the way we do it is we'd use our probability density function, and so we'd have to compute the probability equals a certain number of successes, which would be, in this case, say n choose I, p to the I, 1 minus p to the n minus I. Or we could use the binomial PDF we used before. As an example, let's say x is going to be a binomial with n equaling 11 trials and a probability of success equaling 0.3. So x is going to count the number of successes in 11 trials, and we want to compute the probability that we have at most 2 successes. So x is less than or equal to 2. Well, the long way would be to go, that's the probability that we have no successes, plus the probability that we have 1 success, plus the probability that we have 2 successes. We stop at this case because k is 2. Now using the binomial PDF over and over again, we'd find out that that probability is 0.3127. A shorter way to do that is to use the binomial CDF option in the calculator, the Binom CDF. Now to use this, you got to enter 3 numbers, an n, which is the number of trials, p, which is the probability of success, and then what you want to be less than or equal to. In this particular case, n is 11, our p is 0.3, and we want to be less than or equal to our k, which is 2. So to compute the probability that we have at most 2 successes in 11 trials, what we need to do is hit on the second button and then hit on vars, and then we're going to arrow down 11 times to just past the one that says binomial PDF. We're looking for the one that says binomial CDF. So you can see there it says binomial CDF right after the one that said binomial PDF. Then we hit enter. Then we have to type in the number of trials. In this case is 11. That's our n. And then a comma. Then we got to type in our probability of success, which is 0.3. And then another comma. Then we got to type in what we want to be less than or equal to, which is 2 in this case. And then we close our parentheses and we hit enter. And that's going to give us our probability of having at most 2 successes. Now other calculators will work a little differently. Still starts out the same way. We're going to go up to second in bars, and then we're going to arrow down again to that binomial CDF option, and we'll hit enter, and it'll bring up the little menus here. And so the trials is our n, that's 11. The p is the probability of success, that's our 0.3, and the x is the less than or equal to's, and that's going to be 2. Then we go down to paste and hit enter. And what you'll notice you get on the screen, it says binomial CDF just like we had before, with the 11, the comma, the 0.3, the comma, and then the 2 with the closed parentheses. And if you hit enter on that, we get the same probability of having at most 2 successes in 11 trials.